to talk a bit about some of the science behind soil health, and I'm going to talk about some of the opportunities, some of the challenges that we have for putting it to practice. And I'll tell you a bit about our new Soil Health Division, because that's really where we're going to be driving things from NRCS, and we want everybody to get involved. It's going to be very much a partnership effort. My road in soil health, I think, sometimes I can say, well, it really kind of started very early on. I've gardened all my life and things like that. But where I got really inspired to work on soil health was when I went to Madagascar as an undergrad. And in this country, we're pretty insulated from agriculture for the most part. Only a couple of % of our population is actually actively involved in farming. And the rest of folks, really, a lot of the time, don't have any idea. Well, in Madagascar, almost everybody was either involved in farming themselves or was at least related to somebody who did. Really, everybody knew about it, and it was very, very clear. The rivers ran red, the soil was flowing off the country into the ocean, and a lot of people were very, very poor. I mean, this family, having 2 oxen and a cart, that made them one of the richer families. Their houses were about the size of a king-size bed in terms of floor space in that area of the country. They really didn't have much to speak of, and the people who I've met who had more of an education, more of an understanding of how soils worked and how they could manage them better, those were the people that had more money, that had the ability to get their kids an education, to get their kids clothes, to get their kids good, nutritious food. They were growing more diverse crops. But most of the country was just so poor, and you could see it walking onto the farms, hillsides just giving way. If you go to Google Earth sometime, for those of you who like to do that sort of thing, Google Earth, go to Madagascar, zoom in on some of the landscapes, and you'll find these big gaping holes in the landscape where just whole hillsides are giving way, and all that soil is just flowing away off that country, taking away their productivity, taking away their resilience. And that's where I really saw that close connection, where we as a people have the most impact on our environment, on our relationship to everything that keeps us alive. It's in agriculture. That's where we can make a difference. That's where we're the most connected to nature. And soil health is really at the core of everything that keeps us alive. So here's where that journey started in a much more concrete way than any time before. And at this point, we really have a lot of challenges globally to think about. We're all going to need to be working with the fact that we have a growing population. We're going to be hitting 9 billion, 2050, 2040, 2060, whenever it's actually going to happen. But all those people are going to have to be fed. A lot of that increase is going to happen in places like Africa, where soil health is the most dire in terms of a need for us to do something. But even in this country, across the country, I've seen degraded soils. When we look at what's happening in this country, we are seeing that more and more, especially of our agricultural land, is being built on. That means that we have less land on which we're trying to grow more. How is it we're going to do that? It's a pretty big challenge. We have water challenges, and you guys are well familiar with those. I've been hearing a lot about how in Kansas we go all the way from 16 inches to 45 inches of rain. You have very different climates across. And then we have the variability that we got. Some years we got intensive droughts, and you guys have experienced those. Some years we have floods. Some years we have both. We might get floods like this in the spring, heavy rainfall, plenty of water. Gosh, if only we could store that up. But it ends up causing floods, flooding rivers, wreaking havoc, instead of being stored in that soil because that soil is no longer functioning. And then later that same year, we may have a drought. How are we going to fix those issues? If we could figure out ways to store all that water, we'd prevent the floods, and at the same time, we could have that water later to use it with our crop. How are we going to do that? Water quality issues nationally. Sadly, we haven't really made progress. When we look nationally at our water quality data, if anything, we're stagnant, but in a lot of places we're getting worse. So that's all kind of depressing. So before I depress you more, I'll say, well, actually, there's great solutions. Those are all big challenges, but the great message here is that we, as agriculturalists, actually have win-win opportunities where we can help solve those issues, and feed ourselves. You know, we can feed ourselves, we can have higher profits, we can save the environment. How much better could it be? Can it really be true? It kind of sounds like, oh, that can't be true. But what I'm going to tell you is that really soil health is at the core of all of that. If we can manage for healthy soils, we're going to go a long way towards solving a lot of the issues that I just brought up. So what's that potential? The return on our nation's investment in soil health could bring us all of these things. Better nutrient cycling, better pest suppression, better carbon sequestration, combating climate change, energy savings, water infiltration, that means less runoff, less erosion, less flooding, water storage and therefore greater availability, resilience, biodiversity, groundwater and clean water and air, long-term economic viability, and sustained reliable productivity to feed those 9 billion. Sounds like a great list, right? So how are we going to do all that? Well, when we talk about healthy soils, I'll first define it. I think the simplest definition that's the easiest to remember is just the continued capacity of the soil to function. If you can remember that bit, then we can carry on the rest of the conversation. Well, how does it need to function? What does it need to do? What do we need it for, right? The soil's alive, and I'll talk a bit more about that. And we need to keep that functioning. That's driven by those living organisms. We need to keep that working. This right here is an example of just how much our human management can affect soils. Both of these soils are a Buxton silt loam. It's a soil type in New Hampshire. I spent a lot of time in New Hampshire because I grew up there for a while and then came back there and did some work with NRCS while I was at Cornell. This farm right here is a mixed organic operation. They graze cattle, they've been haying for a long time, they grow vegetables, they grow grains, they grow biofuels, they kind of do everything under the sun. They have perennial crops, they've been doing more and more cover cropping. This is what their soil looks like. Nice and dark, lots of organic matter, well aggregated. They're not having troubles with their soils really. There's a couple of things that they've been needing to fix, and we identified some of those, and you'll hear more about them in a little bit. But overall, pretty good soils. This right here is the same soil type. So if you look at a soil survey map, you're going to see Buxton silt loam. It'll describe what that soil is like. But when you go to that farm, you see something very different. You see that the aggregates are falling apart. You see crusting at the surface. You see cracking. You see that there's, tracks from the machinery that stay there. And this farmer was basically telling me, yeah, I've been trying to grow sweet corn, and I'm wondering at this point whether I even want to keep that up, because it's not really making me any money anymore. I used to grow strawberries in this field. I can't seem to get strawberries to grow anymore. They just keep getting disease, and it's just not working. This is a long-term conventional vegetable operation. They had no cover crops, they had no compost, they were tilling a lot. They weren't feeding the life in the soil. And so now they've got these kinds of issues. And yeah, both of them, you submit a soil test to a standard soil testing lab for pH and nutrients, and actually this one shows up as better. There's some issues there. We're obviously not looking at the whole picture. There's a lot of opportunities. There are practices across the US right now that are being innovated on. No-till's been around for a long time. This is an example of a long-term no-till set of plots that we had in northern New York that I worked on. And basically, after Hurricane Irene came through, did a whole lot of damage, we went to those plots. Basically, the no-till crop was mostly still standing. And in the plow-till plots, most of it was flattened to the ground, pretty much a lost crop. Those are the kinds of resilience events that you don't plan on this in research, you don't plan on that on your farm, but we pick those up and we say, wow, there's really something to this whole soil health thing. Resilience. We can build that resilience. We can build the ability of our systems to withstand those extreme events. Here's a across the fence row example. Brookings, South Dakota, no-till on the one side, conventional tillage on the other side. Heavy rainstorm came through, and you could have driven and probably planted in this field day 2 or 3 later, and here we had puddles, crusting, puddling, for several days, couldn't have gotten into that field, stressing the crop. We see these kinds of differences with extreme events. No cover crop versus cover crop. Look at that water. It's carrying away that soil. It's dirty water. There's a lot more water that comes off of the field when you don't have a cover crop growing. Here we've got a cover crop, roots straight down into the ground, creating a nice even channel all the way in that water can follow. So yeah, we're still getting some runoff, but look, it's a lot cleaner. Here's a study from Maine. This is from our Deputy Chief for Science and Technology at the NRCS. He used to be with the ARS, the Agricultural Research Service, and this was an example of a study where they were looking at various systems of potato cropping, and here we had a conventional potato system versus a soil improving potato system with a lot more organic additions. And after a droughty year, you can see that there was a lot more yield there. Looking at the CTIC survey, cover cropping versus not cover cropping. In that survey, farmers who reported that they had been using cover crops after 2012 in drought states reported having gotten more yield than those who had not been using cover crops. Because cover crops help that water actually get into the soil, and therefore it's available later in the season. These are the kinds of impacts we can have with our management, folks. There's so much that we can do, so much that we can affect, both for our own bottom line and for the environment as a whole. Take all of that somewhere totally different. I did some work in Kenya while I was at Cornell. I'll tell you a little bit more about the soil health assessment that we developed later. We basically went with that soil health assessment to a chronosequence where we looked at primary forests and then subsistence agriculture with basically no inputs, corn on corn on corn for 2 years, 5 years, 10 years, 80 years. And we could pick up that degradation. This is aggregate stability, majorly went down over time. Organic matter content majorly went down after time. And we know we're looking at some good indicators because when we just counted up the number of indicators that were constrained and looked at yield, we could statistically pick up that yield went down. We could predict 50% of the variability in grain yield just by looking at the number of indicators where we said, okay, this is a constraint, this is something that needs to be fixed. So we're getting there, we're learning more. We still have to learn more. We still have to learn a lot more about how to assess for soil health and how to give everybody recommendations to manage that. Because right now, yeah, we can tell you, yeah, put on 50 pounds of phosphorus, but can we tell you how to fix your aggregate stability? Well, arguably, yes. Can we figure out whether yours is too low? We're getting there, you know? So, what is it about soil health? It's this broader picture. We're no longer just looking at the chemical component of soil health. We need to look beyond that, and I think you guys all know this. I'm getting the impression this is the kind of crowd, you're kind of at the forefront in front, you're pushing the envelope. You know, we know that there's more that we need to be looking at. The physical, the biological functioning of the soil is critically important, and we need to manage that just the way that we've been managing our nutrients. Aggregates are like a house, I like to say, and this is a nice one because everybody can relate to why we need our houses. It's our habitat. It's where we live, it's where we function, it's where we have these kinds of meetings. We want our big rooms, we want our hallways, we want our cities, we want our ways of transporting water. Well, in our soil, we have a mega city. Next time you walk out on a field, think about that mega city, homes upon homes upon homes, and roads and aqueducts and everything in between. In just a handful of soil, there are more organisms than there are people on Earth. And those organisms build that house. Those organisms build the pores that move your water, that store your water, that move your air back into the soil. To demonstrate that a little better, I brought our sponge demo, because soil is kind of like a sponge, and we can have that good, healthy soil that has those large pores, those intermediate pores, those small pores. All of those pores are critical. So I have a sponge here, and you know, in Kansas often our soils dry out, so I left this dry. And you know, I can kind of still squish it, you know, it's not totally hard, but obviously soils get hard. And when the soil is dry, I'm not sure if I'm going to be able to do this with a microphone, so I need my 2 hands. So if you can't hear me, then let me know. I'm going to put this here. For soils are dry and it first starts raining, right? If we have a good soil with nice large pores, it can rain a fair amount and that water will actually go straight in. I can pour water on this sponge that's got those larger pores, and that's doing fairly well. And yeah, if I started to pour a whole lot faster, eventually you're going to get some runoff. But I can get this sponge to wet up pretty well. And it's going to keep going through. See, the bottom's already plenty wet. That's what we want in a healthy soil. When it rains, we really want it to completely wet up. We want that water to be able to recharge the deeper root zone and to recharge our groundwater. And we haven't been doing that very well. Well, we get a lot more rain, and we can get some pretty saturated soils, right? So it rains, it rains, it rains. All right, we've got our saturated soil. First thing when it stops raining, first thing that happens, got that saturated soil, stops raining, that soil is draining. In a healthy soil with large pores, you're going to get a good amount of drainage. And guess what? What else that means is that as that is draining, it's pulling air back into the soil. The only way that those plants can survive is having both enough water and enough air, because plant roots need oxygen just like we do. The only way air can get back into that saturated soil is by the water pulling the air back in, sucking it back into the profile. If we don't get that drainage, it's going to be very hard to get that air back in. Now it stops draining. We're at what we call field capacity. At field capacity, generally a soil is in pretty good shape. Those plant roots are not stressed. They've got plenty of air. They've got plenty of water. Now that plant is going to start using up that water. Plants suck out the water. I'm going to squeeze out the water, and we can squeeze out plenty of that plant available water. This is our available water holding capacity. How much can that soil hold? How much pore space is in those medium pores after your drainage is done that's being held? This is what carries you through a drought. If you have a week, if you have 2 weeks, do you still have enough water? After 3 weeks, do you still have enough water? If your root zone is 3, 4, 5 feet deep, if your root zone is that over there, that wonderful picture from the Land Institute, right, and you have deep roots, guess what? That entire soil profile, if it's recharged with water, if you manage to infiltrate that water and store it, it's available. And your system can be pretty resilient. Now, we can't make it rain with healthy soils. So if you really truly have a drought, eventually those plants are going to get to that point where they just can't get any more out, right? Well, that's our unavailable water, right? The sponge is still wet. There's still some water in that soil. But the way that soils are is they have these tiny little pores that hold onto water so tightly that no plant can get at that water. Now, some plants are better at getting at that than others. This is where you get some of your more drought-resilient plants. But eventually you get to that point where we call it permanent wilting point. You just can't get any more out. But there can be a pretty good range in between there with a deep soil profile with good water storage. Now, what if your soil is not healthy? A lot of soils that no longer have those organisms building that house are much more like this sponge. This sponge has small pores. With compaction, one of the first things that happens is you lose your large pores. That is the definition of compaction, is the loss of large pores. That happens if your organisms are no longer functioning well enough. They're not able to keep up with all the disruption that's happening in that agricultural management system. If you're tilling a lot, you're not feeding your microbes carbon, they can't keep up. They're not keeping those aggregates built. Who's walked out on a soil that basically is hard like that? You recognize that? That's a soil degradation issue. It's a soil health issue. Well, we have a soil like that, and we get some rain. What happens with that soil? Well, I'm not pouring faster than I was before. Actually, I can slow that way down. And it's not going in. I've managed to wet that a little tiny bit by pouring something on right now. You know, we can keep it raining. We can rain faster. Okay, we're going to flood, and I'm going to make a mess here. Sorry about that. Should have brought a bigger tub, right? So, you know, we can try to pour on this, and I think you get the point, right? I mean, I've still got a solidly hard sponge here. We've just started to wet the surface. Who here has gone out after a 2-inch, 3-inch rain into your field and dug down and see whether that soil actually fully wetted up? Have you ever done that before? It's a really interesting thing to do. It really tells you something about your soil's health. Because if you can go out there and you've just gotten all that rain, 2 inches should go down at least 6, 8 inches in your soil profile, and you should be soaking all that in and restoring it. But so often, you go out there, you see a muddy crust at the top, and you dig down and maybe it's wet at 2 inches. Well, that doesn't help anybody. That means all that water that you could be using, that's the resource that you're looking for. That's what you really need, especially in a place like this where that's the limiting factor. If you're losing it all, and it's turning into floods and dirty water and Mississippi River Basin issues, that's not what we want. What we want is to use that resource to get it into the soil. Well, here's that sponge, that really unhealthy soil, that eventually dunking it into water, I can get it to wet up, right? So now I can start to squeeze it. Well, here's the other side of this issue. We've now had a saturated rain kind of event. We've rained and rained and rained, and it stops raining. There's a little bit of drainage, not much. Guess what? Those roots are really having troubles because they're sitting underwater. They can't breathe. Not only was your crop stressed because the soil was hard and dry before, but if you do manage to get water in, if you do manage to saturate that soil, now it can't drain. Now it can't bring that air back in. And so your roots are sitting there, starved for oxygen, not able to do anything. So now you've got issues on both ends, right? Whether it's super wet, whether you've got a drought, you've got this kind of a soil that's basically stressing your crop. This is why we need to feed our soil organisms. How many here have livestock? How many here are farmers? I think there's more farmers in the room than said who had livestock. Every one of you who's a farmer or even a gardener has livestock, because your livestock are in the soil. And you wouldn't think to not feed them because, you know, this is the kind of stuff we just talked about. They're building those aggregates. You need to get that water into the soil. You don't want it running off. And guess what? There's a nice physics equation for those of you who maybe geek out on physics a little bit. The water movement rate into the soil is a constant times the radius to the fourth. What that means is that if you shrink a pore to half its size, the rate of water movement is 1/16 of what it was before. That's a big difference. That's why we need large pores, right? You don't want to lose those large pores because those really rapidly bring that water in. We want to keep them that size. All these organisms, here's your livestock. What do they eat? They eat carbon, they eat organic matter, they eat biomass, whether that's manure, whether that's root exudates, whether that's various crop residues that fell on the surface and the earthworms drag it in and pull it into the soil, and then some of the arthropods shred it and some of the bacteria and fungi start to decompose it. Where all of this starts is we get energy from sun, plants photosynthesize, we all learned this a long time ago. They use CO2 out of the air to make that biomass. And roots are very leaky for good reasons, because our plants depend on these microorganisms, and so they know to feed those microorganisms. So our plants are constantly leaking carbon into the soil. And when plants die, or actually even while they're alive, constantly roots are dying off and new roots are growing. And all of that organic material, that is the feed for your livestock. That is what starts feeding this whole web, where some of these organisms eat that stuff directly, and some of these organisms eat the next organisms, and it's a jungle out there. You've got nematodes eating nematodes, and nematodes eating fungi, and fungi eating nematodes, and everything. But it all starts with that biomass, and all of it originally comes from plants. So guess what? If you're growing corn, and you plant it in May, and you harvest it in October, say, what happens between October and May? You're starving your livestock, unless you figure out a way to get a cover crop in there, which is really challenging in Kansas. And I thoroughly understand that. And it's one of the things we're working on right now is, how do we do this? How do we, with our annual cropping systems that aren't what used to be here, but that is what's functioning for us right now, how do we keep that underground livestock fed? How do we make that happen? Are there some cover crops that can work here? Are there some different rotations that we can use so at least more of the time we can get some of this organic matter in? Can we at least have more mulch in place so that some of these organisms can pull some in? You know, what are those solutions? We're not fully sure yet, but there's some innovators amongst you guys that are figuring out some ways to make it happen. And those are the folks that we want to learn from so we can spread that message. So how do soils degrade? You know, if we intensively till, basically what that starts to happen is we're not feeding enough residues, we get lower diversity, we have no surface cover, we start to lose our soil organic matter, it decomposes, we get erosion, subsoils get compacted, we start losing that house, those aggregates, surface becomes compacted and crusted, now we get that lack of infiltration, more runoff, more erosion, both wind and water. Now we lose more soil organic matter. We lose our nutrients. We lose our topsoil. That's the best part, folks. That's the part that grows your crop. That's the part that keeps your farm alive. We get more ponding, more persistent wetness, and more drought issues. You know, the things that we just showed. All these different things start to snowball. Less rooting, lower nutrient access because those crop roots just can't get to the nutrients because they're limited by something else. Less diversity of soil organisms. That often means we get more disease. That means that crop yields decline or our inputs have to go up to compensate. And not so much here, but certainly in the developing world, we get hunger and malnutrition because of soil degradation. It's a pretty dismal cycle. How do we get out of it? How do we get out of that tillage addiction? I really like to talk about tillage addiction because it's again, something we can relate to, right? Whoever here has been addicted to coffee, you know you can't just quit cold turkey. It's really painful, right? And so if you have a really degraded soil and you go straight to no-till and you don't do anything else, you're probably going to fail because the soil can't handle it. So we need to reinvest. We need to take that spiral and kind of turn it on its end, right? If we have compaction, we increase our tillage. That means we decline our organic matter, we damage our microbes, we reduce our aggregation, we get poor drainage, that means we have more compaction, that means we go back to more tillage, right? It's this kind of spiral that makes it happen. It's an addiction, you know? The more you have a headache, the more you drink some more coffee. The more you get tired, the more you drink some more coffee, and then you get more tired the next day, and blah, 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 you know? We know what it's all about, right? So this is happening in our fields. We gotta turn it upside down. We got to turn that spiral into a regenerative spiral where the more good things we start investing in, the more we get ourselves out of that hole and build our soils back up. It's kind of like a bank account, you know, you can get a lot of interest off of $1 million, but how are you ever going to get to $1 million, right? But we can slowly build up that bank account. We can slowly get to a point where there's more that we're getting out of that. And so with our agriculture, you know, if we reduce tillage, we don't have to go straight to no-till. But maybe there are some places where we can reduce the intensity of it. We can increase the biomass. We can increase our rooting, right? What crops can we get in there that maybe have bigger roots, deeper roots, stronger roots that are more able to get through that compacted layer, you know? Higher diversity. How can we get some more diversity of crops in there? Can we just even introduce one thing? We start to get into that direction. Surface cover. Can we keep the surface covered so at least when it rains we don't get an immediate crust, right? So then we start increasing our organic matter. And it's slow, folks. You know, we didn't get here overnight. We didn't degrade our soils in one night. We got there over a long time. Well, it's going to take some time, but we can increase our organic matter. We can reduce the compaction that's there. We can start to get more water into the soil. We can decrease our erosion. We can rebuild our aggregates. As our aggregates build, we can get that soil back to functioning. We can increase that available water holding capacity. Now we can grow a little bit more because we can hold that water a little longer. We get even more infiltration. We get even less erosion by wind and water because those aggregates are more stable. We can build yet more soil organic matter. We can get those nutrients to actually be stored in the soil and be recycled so we can use them. So now we can start to decrease some of our inputs. We can build our topsoil. Now it's more productive. It's more resilient. We can use less energy on tillage. Again, we're cutting our inputs. We're decreasing our costs. We're storing more water. We get better rooting. We get more nutrient access. We get greater soil organism diversity. We get less disease. Again, cutting inputs. Maybe staying at the same yield, but especially in those really tough years, we're going to increase our yields over that of our neighbors because our system is more resilient. It's more able to deal with these things. Field conditions, as they become more resilient, more consistent over time, we're going to increase those yields, lower our costs, lower our risks, and get all those environmental benefits that I talked about. We can do this. It's going to take some work. It's an investment. You know, if you buy a combine, you recognize you're going to take out a loan. It's going to take some time to pay it off. That's what we need to do with soil health. And it's tricky because we can't just give you a number the way with a combine we can say this will pay off for itself in 5 years. We're still trying to figure out those numbers. But we know the concepts. We know that this stuff works. And there are farmers who can show it because they've been doing this for 10, 20, 30 years and they're having successes. Right? So we need to learn from those folks. So the NRCS has had a soil health campaign going for the last several years. And I think we've had a lot of success. It's been really exciting. Awareness is growing by leaps and bounds. There's a national meeting of all the soil scientists I'm going to next week. And there are something like over 80 presentations on soil health in the program, which is a lot more than it was the year before that, and a lot more than it was the year before that. And we see this in agriculture. Everybody's starting to talk about soil health, right? So we're increasing that awareness. There's farmers out there doing it. There's profiles online about these various stories from all across the country of farmers who are having successes. It's also raised a lot of really good questions. You know, a lot of scientists have come to the NRCS and said, wait a second here, you know, what's the science about behind this? And so we're going to be working with those folks a lot more. A lot of farmers are coming to us and saying, you know, this all sounds great, but how do I do it? Well, that takes more capacity. We've gotten to the point where we can lay out these 4 principles of soil health management, right? We can minimize soil disturbance, we can maximize diversity in our system, we can keep the soil covered, we can maximize living roots. But how we actually adapt those soil health management principles to soils, to regions, to cropping systems, that's going to require really broad collaboration from everybody. NRCS isn't going to do it alone. We're going to work with everybody. Anybody who wants to work with us, I think the more the merrier, because we're not going to solve this problem overnight. We're not going to do it alone. We all need to work together, and we need to use everybody's perspective. How are we going to work on this? So, luckily, NRCS has some really forward-thinking leadership. This ground-up movement where farmers have been saying, gosh, I'm having success with this, or gosh, I'm having these problems with soil health. That message has made it up to leadership, and they decided, okay, we're going to create a whole new division that focuses on soil health. A whole 20 people that are charged with soil health, getting the message out, providing training, a whole bunch of other things. This is what that division looks like. I'm the only person that's based in DC. The whole rest of the division is spread across the country so that we can really get that local knowledge and bring it up to headquarters and make sure that NRCS programs, voluntary incentive-based both payments and technical assistance, that those can be done in ways that work for folks. So we've been hiring. Basically the last year I've spent a lot of my time on trying to make sure that we make good selections once we were allowed to do that and bring good people in. We've got Candy Thomas in the room here as our new regional soil health specialist. She's in Kansas and Nebraska and wherever else we'll need her. So make sure to meet her if you want to wave for a moment so everybody knows you're there. She's there, so make sure to connect with her. Make sure to voice, whatever interesting opportunities you may see, whatever concerns you may have, questions and all that. And we want to pull on that information and make sure that we see what the trends are across the country and see that we can leverage that and really move things forward faster than we could with all these little groups working separately. We're going to be trying to deal with all these various issues and opportunities, right? I mean, we've got agricultural production systems across the country that are extremely diverse, soils and climates that are extremely diverse. We've got research partners all across the country that we can leverage. We've got various efforts in NRCS and USDA going on, like the climate hubs, the plant materials centers, critical conservation areas. There's a lot of stuff we can leverage. And so we've placed our people all across the country to try to make sure to build all those partnerships so that we can move this forward. What are we actually going to be doing? Well, here are some of the main goals we're going to be working on. Soil health training. We're going to be putting together some advanced training so those of you who are farmers can go to your county NRCS field staff and they can provide you better and better advice on how to manage for healthier soils. So that we can put in place soil health assessments. We're going to be working with partners and really trying to get at how do we standardize soil health assessments enough that, for example, NRCS hopefully will be able to cost share for it. Soil health management planning. If we actually know what the status of that soil health is, what the problems are, we can learn to fix it better. We can give better recommendations. put planning together, get soil health management systems implementation working on the ground, make sure that we observe how that works, get feedback from everybody and feed it back into the system, because we know we're not going to get it perfect. It's always how it happens. You put some programs together and then, oh wait, that didn't work so well. How are we going to fix it? We need that feedback, right? We want to hear from everybody. We're going to be leveraging partners to try to make sure that we do this well. We're going to ensure the scientific basis. We've got a bunch of folks who can really review the scientific literature and interact with those scientists so that we can keep learning, because there's a lot about soil health that we don't actually know yet. Hopefully we can quantify the benefits, so that we can say this is how much impact we've had, so we can keep this program rolling. And the economics are a really big piece of it. If we could tell you, if you invest this much and do this for soil health right now, this is how it'll look for your bottom line in 5 years from now, 10 years from now, that'd be great. Right now we have a lot of anecdotes, but we don't have tools or calculators that can show you those economics, and we're very aware that that's what a lot of the section of agricultural producers want, even though there's a lot of folks who just want to do this because they know it's the right thing to do, and they know enough neighbors that have made it work that they say, yeah, I'm on board with this, I'm going to try it out, I'm going to make it work on my farm, I don't care where the science is at, I'm going to just move it forward. And those are the innovators that we learn from, and it's really exciting to see that happening. So I just want to give you a very brief example. One example, I know it's not from Kansas. Hopefully pretty soon we'll have examples from Kansas. This is an example from that farm in New Hampshire, the mixed organic operation, that did have some issues. We had this field with a pond at the bottom of the field with some grasses that were growing all right, but maybe not the best of productivity. The major issue was in the pond. This algae right here is a clear sign that there's eutrophication going on, which is a fancy word for saying there's too much phosphorus getting in the pond and the algae are just blooming like crazy. This used to be their recreational pond. Well, it's still maybe okay for irrigation, except it takes some more filtering, but you're not going to want to be swimming in that. There was a bit of a slope going up the side of this hill, and they have been basically grazing and haying it. So it kind of looks like a perfect soil health management system. The soil is permanently covered, there's living roots growing in the system year-round, there's a fair amount of diversity in that grass, we've got the soil covered, it's there, but it's not. What's going on? Well, this is where soil health assessments come in. And if we look at a standard soil test, it was actually kind of puzzling. A standard soil test, we see our pH, okay, it's kind of on the low side, but 6.1 isn't too terrible. Extractable phosphorus, gosh, wait a second. Extractable phosphorus was actually kind of on the low side, if anything. It was definitely not too high, but there's too much phosphorus in the pond. Potassium was kind of on the low side. The minor elements, several of the micronutrients that we tested were just fine. What's going on here? This is puzzling. We've got a clear issue. They're following all the rules. They're staying away. They've got that buffer zone, no manure within 50 feet of the pond. Well, we looked at a full soil health assessment. So this is the assessment that while I was at Cornell, I helped develop with a team, where we actually started measuring physical and biological indicators of soil health, as well as chemical indicators. The way to read this, so there's aggregate stability, available water capacity, surface and subsurface hardness, some of the concepts we just talked about. We measure those as indicators in the lab. We measure a value and then we give it a rating. And the simple way to say this is it's like a traffic light. You look at it, green, you're good to go, no problem there. Great aggregate stability, great organic matter content, some 5.3% organic matter, that's pretty good. It's mineralizing nitrogen pretty well, all right, but we're seeing a lot of yellows. We're seeing a big red there. Well, yellow, okay, caution, you might have to stop. Red, okay, there's a major constraint there. Stop, you got to look at that one. That one's your constraint, your biggest constraint, you got to manage it. And because of the way the rating system works, it's on a 0 to 100 scale. At 30, it drops you into a constraint. We can start to look at some of these yellow numbers and actually not just surface hardness is in the red, but subsurface hardness at 36 is pretty close to that red. So basically, pretty simple. We've got major compaction issues. That issue that I just showed, right? Remember that really dense soil, pour water on it, runs right off? Well, that was the issue that was happening here. Yeah, there were grazing animals, and then all of the manure wasn't able to get into the soil. So we didn't have enough phosphorus in the soil, so it was hampering crop growth. But because it couldn't get in, it ran off and so it went straight into the pond, so we had too much phosphorus in the pond. Well, that's kind of a simple thing if you know to look at it. You know, it's kind of like you go to the doctor and you say, my leg hurts, and they say, okay, well, let's measure your blood pressure. If they didn't know to see whether you had a broken leg, they'd be missing something pretty major, right? So with an assessment like this, the idea is, okay, let's measure more things. Let's make sure that we actually look at the whole you instead of just at one particular thing. So, you know, compaction, okay, that's a pretty obvious one. There's various other things that we can look at. In this particular case, okay, we knew that we needed to fix compaction and everything would follow. I know you can't read all this. The basic message here is that what comes with that assessment is, by indicator, there are suggested management practices for the short term and for the long term. And when we worked with the New Hampshire NRCS, we actually attached that to our practice standards so that the folks in New Hampshire could work with the NRCS field staff and say, okay, if I have high surface hardness, I know that either, you know, shallow rooted cover crops or a living mulch or interseeded cover crop or some mechanical loosening or some short-term solutions to fix that surface hardness. In this particular case, we said, well, we've got our rooting and it's not fixing the issue. Okay, maybe we need to actually go in and do a little bit of investment, a little bit of loosening, and bring the system back. So we developed a soil health management plan and went in. They had a yeoman's plow, which is basically a deep shank kind of ripper, and despite the fact that they had some rocks, the farmer was like, yeah, I'm just going to try this out, no problem. We ripped along the contours of the field, so now if it rained, the water basically went on and ran into a slot instead of all the way down to the pond. We actually went across with an airway as well, so kind of loosened up the surface, but not enough, you know, not so intensively to destroy the grass, just to loosen it up a little bit, release those roots. You remember that pH was a little bit on the low side, phosphorus and potassium were on the low side. Okay, well, they have plenty of wood ash in that part of the country, and so that's what they decided to go with there. And then actually seeded in a mix of a cover crop in part of the field that was hairy vetch, winter rye, wheat, and barley. And in this particular case, they used a 3-inch rotavator, sort of a bit of a gentle till. We had talked about no-till. They didn't have access to the no-till drill at the right time. You kind of adapt, you know. They got that growing, and here's the results. They managed to get a really nice crop from that mixed cover crop that they could harvest for forage later. In the rest of the field, just alleviating that compaction and adding a bit of those nutrients. I mean, we know that part, but doing those two things, the clover came back. They got a great clover crop, much, much better feed than I had before. And just a year and a half later, that pond totally cleared up. So these are the kinds of results that I bet we can achieve across the country. And it's going to look different in every production system. The solutions aren't going to be the same. Whether you're on an acre of vegetables or 25,000 acre ranch, there's going to be some very different solutions we need to apply. And that's part of why we need a national team working with the even broader national team of the NRCS field staff and organizations like yours and farmers themselves as we figure out how we put together these kinds of plans so we can achieve these kinds of results. But I think it's possible. And it's going to be a bit of a road. There's going to be challenges. There's going to be opportunities. But I think it's really exciting that we actually have these opportunities, that we now will have more capacity to do that.